Welcome to a new video in my channel, and finally I'm making a new project, or I pretty much done a new project, which a little bit of hardware and a little bit of ESPHome and also Node-RED. And this is basically a digital scale which measures how much water I drink every single day. And the reason this is important because I have a lot of headaches for many years now. And of course, whenever I go to the doctor, it says like, are you drinking enough water? And I said, I guess I drink enough, but I wasn't really sure. So now I have a gauge to measure that and tell me that if I'm not drinking enough. Basically, it works like a digital scale, and I put my water bottle on it, and every time the weight increases, that is considered as the water bottle is being refilled. And then anytime the weight decreases, then the system thinks that I have consumed some water, and it keeps account of that. So it will know if the bottle got refilled, and then from that refilled weight, it sort of counts down, and then it determines how much water I have, how much water I'm drinking throughout the day. So, and of course, the big thing is it also gives me reminders. So at the moment I configured that if I don't drink every half an hour, then it's going to send me a notification that I need to drink. And if I still not drink after about, I think it does it every 10 minutes or 5 minutes, it sends me additional reminders that I need to do that. And the way I've done it is, well, obviously besides the digital scale, which is inside this small contraption, there is a ring light. So I designed most of the notification as a way of different, light effects that come from the ring light. But I've also configured it to send me Telegram messages, which is sending a lot of messages mostly for debugging purposes, but I think I'm going to turn it down and then probably only send me the second notification, because most probably I should be sitting next to here, so I would notice when the light effect comes on, and that would remind me that I need to drink some water. And if the bottle is removed, so that if there is no weight on the scale, it sort of turns it off. So if I don't want to get bothered because I leave to town, or I'm just not around at home, I just wouldn't place any weight on it, and then it would just not do anything. So it's simple as that. So in this video, I'm going to show you how I build the physical thing, and I also going to talk about the ESPHome code, which is running on the ESP8266. And then, of course, I would talk about the Node-RED flow and how you can, download it and how you can customize it to your needs. And I'm planning to do everything in a GitHub, so you would have links to the AliExpress listings where I purchased the various things. There's going to be a lot of 3D files for the base and this sort of enclosure that I designed and printed for it, and of course the files for the ESPHome YAML file and the Node-RED flow for it. And I'm using this project to monitor my water intake and just give me notifications, but it's just basically the scale. So maybe you have similar requirement, maybe you want to measure how much food your pets are consuming, so you can use the same project and maybe just work, you change the, of course the physical holder around, but then change the notifications to suit your needs. And one more little thing about the notifications. So as I said, it handles a couple of different states. So it would know when the water bottle is removed from the weight, and that basically just disables all the further notifications. So if you just get bothered, or you get distracted, or you have to leave the home, you just remove the bottle and then that's it. So of course you have to calibrate the scale to know what is like no load at all. And then of course, when you place a weight on it, that would consider that's the the water bottle with some drink in it. So it would remember what is that basically weight, and then as the weight decreases and you start drinking, then it would measure how much, what was the difference. And again, whenever the weight increases, that is treated as that you just refill the bottle and then it's full again. It doesn't have to be full, it can be any amount, because it always registers that what was the new weight, the new sort of higher weight, and then it starts calculating the reduction from that. And of course I use metric units. So this measures grams, and then 1000 gram is 1 liter, so it's easy for me to convert from let's say, weight to actual volume of, let's say, water that I drink. So at the moment I've configured to give various light effects every time it detects one of these states, and it always registers what was the last time that you consumed the water, and then it's basically going to run or start a timer from that time. And if half an hour elapses, then it's going to give you a first notification, and then if there is no response for any additional, I think it's 5 or 10 minutes, then it will just keep giving you notifications. And that's why I designed this sort of like zero weight off state. As I said, if I need to leave the house, then I can just remove the bottle, and that's going to be it. And just to show you the whole thing, I'm just going to have another section a little bit later when I talk about the internals. So what I have inside is, well, what I have here is this cylindrical shape, and inside you have the load cell, and you also have a vMOS D1 Mini, which is powering the whole thing. So that is connected to the load cell through this amplifier board, and also to the ring light. So that drives the whole thing. And I use the USB, so the micro USB port on the vMOS D1 Mini to power the entire unit, and a regular, USB power supply, like an old wall adapter, which probably can do like at least an amp, is able to provide power for the whole ESP to run the code and everything, and also to power the ring light. And even if I have a light effect like the rainbow light effect at full brightness, it works just fine. So this small ring light, it doesn't take so much power that you would need a separate power supply for that. And I quickly wanted to show you all the different parts that I purchased for this project. So I found this listing on AliExpress, which sells a lot of different load cells, and you can buy the various load cells with the this HX711 amplifier board to it. So that's what it takes, and then you can buy 1 kilogram, 5 kilogram, 10 and 20 kilogram versions of it. I mean, I have a half a liter bottle, so I bought the 1 kilogram version. And yeah, it works fine. It doesn't cost a lot of money. And for the ring light, I actually found the same on the very same seller, and I bought the biggest one, the 24 pixel version, which was big enough to fit around the whole thing. Okay, so let me give you a quick look at the hardware. As you can see, it is partially assembled, and this is how I was using it up until now. So actually, since it's working now, I thought I'm going to shoot this video quickly when we can see the innards, and then I'm going to put this side thingy on. So nothing much going on. I mean, obviously the hardware is really simple. We have the vMOS D1 Mini here, and then we have the amplifier board, which comes with the strain gauge, and then we have the ring light, and that's pretty much it. And everything is made of two 3D printed parts. So you see this, I have this base, which, I mean, these are just some IKEA feet. And then there is this diagonal stand the strain gauge sits on, and that is secured with a screw. You can see here, I think it's an M4 that you can screw in from the back from here. You can see the screw down there. So that's how you secure the one side of the strain gauge to the whole assembly. And on the other side, I mean, I guess I could have 3D printed this top part as well, but I just had some 4mm acrylic, and I thought that's going to be more rigid than 3D printing anything. Probably if I would 3D print this one, I would, well, definitely 4 meter thickness, but I might have to just print it like 100% in film, just to have enough strength. Although 1 kilogram of load is not a lot, but you can see how it works. So if I apply load here, then, well, okay, that has a little bit of flex, but obviously it's pushing this part down as the arrow indicates. And then that's how it's going to measure the weight by the strain on this upper part and also the lower part of the cutout from this metal piece. And well, this is why it has 4 wires, because it's obviously measuring on both places, and it's either to, and this PCB can work out the actual, from the stress it can work out the load on this load cell. And basically I just hot glued everything into the base. So I designed all these PCBs to stand up. I also 3D printed a piece of guide here as part of the 3D printed design, but actually it's I think it was a little bit short, so I ended up cutting the ends of it so it fits better. And then the ring light is also glued on it. And of course in the final assembly, so that was one 3D printed part, I have all this, also this wavy thing that is going to go on top. Well, it's going to go around here, the ring light. Actually, I think I can just thread this through here. So that's how it's going to look like. And the cable is going to come out through here somewhere. Yeah, you can see. I might have to make this hole a little bit bigger in order to get the cable out. I'm using a piece of USB cable which is a little bit rigid, so I think I'm going to just cut it out. And I also have this mat past that. So that's, I think I'm just going to use some double-sided tape that to go on the top. So if I ever need to disassemble it, I will be able to disassemble. So that's this is what I call the top decorative piece in the 3D printed model, and that's the actual thingy. That's the actual base, and as you can see, oops, where is my focus? And you can see I created two spacers. So that's an 8mm of spacer under the 4mm acrylic, just to keep this above the sort of this side. But again, you can modify the design a little bit. I think there is space to make this less tall. I mean, definitely you can see that I could have made this probably like a good centimeter lower just to make it more compact. But when I went through the design of this, it ended up being, this tall. So I thought I'm just going to leave it as it is and just make this whole assembly taller. But that's it. I almost forgot to talk about the wiring, but well, you can see it here now. I don't want to go into the exact details because I included all this wiring diagram in the GitHub as well, and a small table which shows all this wiring if you prefer to read it instead of looking at these pictures. What I just want to mention that the strain gauge, well, at least the one that I ordered, comes with these 4 wires with these color codes, so that's how you connect it to this amplifier board. And this amplifier board needs 3.3 volts, so that is connected to 3.3 and also ground. And we are using D1 and D0 for the 2 data lines, well, the data and the clock lines, you can see them here. And then besides that, the NeoPixel ring obviously uses 5 volts, so that's connected to 5 volts and ground, and the data line is the RX pin, which goes to the D-in or DI pin on the NeoPixel light. And again, just because there is this cover around the NeoPixel, I soldered the lead so the lead come towards the inside of the NeoPixel and not the outside. It would have been really difficult to route the wires back through. So that's just the tip. And of course, this wiring diagram doesn't contain anything related to power supply, but as I said, everything is part of the micro USB port here on the vMOS D1 Mini, so there is no separate line for the power supply. And then obviously the internal LDO for the ESP provides the 3.3 volt, which is, it's good enough for this amplifier board as well. And the 5 volt from the micro USB board goes directly off to the NeoPixel light. And yeah, like a general 1 amp, USB power supply is good enough to power this project. Let me go through the ESPHome YAML file as well quickly. So first of all I created a substitution because I'm going to use this device name later on down in the file in a few places. So this is now called the water scale. So some of the MQTT details are going to refer to this one. And yeah, it is using an 8266 D1 Mini, and I have a secrets file which where it stores all my password. So the SSID, the Wi-Fi password, and everything is stored there. Same as the MQTT broker details. And again, as I mentioned in in my first ESPHome video where I explained how I use ESPHome without Home Assistant, I said that I have excluded a Home Assistant line or Home Assistant setting. So if you plan to use the same thing in Home Assistant, you might just need to add that. But again, I think in Home Assistant, if you create a new device, an ESPHome device, it will include all the details. So you can just fill in the blanks, or sorry, fill in the, the specifics from my file. So yeah, I mean, I obviously used MQTT, so I created those. And then let's go into the various devices. So the first one is going to be the ringlight. And that's going to be a lot, because what I learned from Home Assistant is you can't create just a generic ring like NeoPixel light, but you also have to specify all the effects that you want to use, and you configure those effects here. So this section is going to be really long, because I customize a lot of different effects in here just to try them out, even though I'm not really using all of them. But the basics is that the platform is NeoPixel bus, the type is not RGB but GRB, and it is a 28 WS2812X, and I connect it to the RX pin, which is GPIO 3, and the number of line is 24. Yeah, and I call it the ring light. And then it has, I specified, I didn't want to use the default state and command topic, so I created my own state and command topic. So device name is water scale, and then ringlight/state and ringlight/commands. And later on, where I'm going to show you in the code how I refer to these parameters, you can see that I have slow random, fast random, rainbow, twinkle effects, random twinkle. So these are basically, I just added everything which is part of the ESPHome framework, and just to try them out. So you can, so yeah, there is a scan, and the last one is a fast pulse. I think that goes around like, no, that's just a pulse. Yeah. Okay, so the next one is a text sensor. Again, this is something that I added from into one of my ESPHome devices, which is going to tell you the uptime in a human readable format. And the next section is the sensor. So this is actually the strain gauge. So you can see that it is the platform HX711. So that's the small amplifier board which comes with the scale. And then the pin out is for data out I'm using D1, and for clock I'm using D0, and for clock I'm using D1. And I think the default gain is 128, and I reduced it. I was just playing around with the settings, and I set the interval, so the update interval, to 10 seconds. Again, I'm going to refer this in other part of the video. I think the default is 30. And I also specified the state topic here. I didn't want that, complicated structure. And yeah, and the unit of measure is grams, and then the filters. So this is how I calibrated the device, the scale. So it actually gives me a gram reading instead of the the raw reading that comes out from the sensor. And I did it for two reasons, because I measured everything in gram, and in SI units, 1000 gram is 1 liter. So it's easy to convert between grams and liters. So volume and the weight. But also the other thing is that you can see the raw values are really high, and then when I convert it to grams, the resolution makes the at the actual gram measurement really precise. So I'm not using any decimal places here, and it looks like that it doesn't really, maybe it only drifts by 1 gram when the the bottle is just staying on the scale. So that just makes it really easy to use this. So when you start, then you comment these 4 lines out. Or when I started, I commented these 4 lines out, and I just turned on the device and I looked in what is the value that is coming. Either you look it in the debug, or if you have set up the MQTT, you look at what is coming in the MQTT. So it looked like that for me, when the scale was empty, it was measuring 57,900. And again, this varies around like 10, 15 values, or maybe even more. It was going up and down by 50. But again, you try to come up with a medium value, and that's going to be fine. So that's the median value. Well, that's the value when it was open. So this is going to be represented as 0 grams. So no weight on the scale. And then I took my water bottle, I filled it up with water all the way to the top. I measured it on my kitchen scale, which was 688 grams. And that was the reading when I placed the bottle on top. So I just put this in, and then it was to 688. So that's basically your linear calibration of the device. So, once you have these two values, you can uncomment these 4 lines, you add them in like this, and the next time you boot up your ESPHome or this particular device, it's going to give you the readings in grams with no decimal places, which is good. And the rest is just like, I have a topic where it shows me the signal strength. So if you're placing this around and it's very, very low, then maybe you can, look at the signal strength. And then this is the system uptime. So it gives me the uptime in seconds. No, I think it does it in minutes. And then that's the one which calculates the human readable format. So it says days, hours, minutes, and seconds. And finally, I also enable this web server. You can delete this part. It's absolutely optional. I just like to have all my devices, if possible, to have a web server. So if I'm looking for a device and I just see like a generic ESP device on my network scan, I just call it up port 80 and it shows me something like a simple web page that this is a water scale. It's not really useful, but it's offered in ESPHome, so I just usually include it. And that's pretty much it. So, the main thing is the sensor and the calibration, the filtering, and then the rest is just the light, and that's pretty much it. And this is the entire Node-RED flow for this program or for this project. As you can see, it's not a big one, and this part is just for testing because I wasn't sure how to use this ringlight functionality. If you don't really care about how this works, then what I would first I would just want to focus on the basics, so how you can implement this project. As I said in the beginning, the link is going to be in the video description to a GitHub repo, so you can grab the JSON file that you can use the import functionality to import it to your Node-RED instance. And the one thing that I want to show here in the beginning is that we have a settings in JackNode. So if you open this up and if you open this JSON, then you can see all the settings. And actually, by the time when I release this flow, there is going to be a comment note here as well, and I'm going to just document all these settings. So this measurement variance is a value because the code is going to wait until it measures the same weight with this amount of difference. So I added this because I didn't want to run into a situation that I accidentally measured the weight when I'm just putting the weight, the bottle on the scale, and maybe because of some dynamic loading, it's going to measure a higher value. So this is why everything is a little bit delayed in this whole application. So when you drink it and you put the bottle back, it's going to wait until you get a notification back, because it does this extra measurement just to make sure it's not detecting any peaks or lower values. So it will keep measuring until it finds measurements within this tolerance. Anything, if you have a value lower than this one, that's considered that the bottle is removed, so the scale is empty. This is the drink alarm. So if you don't drink for more than 30 minutes, then it's going to send you the first alarm. And if you don't drink, then it will keep sending you an alarm every 5 minutes. And this is going to continue forever. And that's the daily goal. So I said I want to drink 2 liters of fluid every day. 2 liters is 2,000 grams of water. So that's the limit. And if this goal is reached, then it's not going to send me any more notifications. And I also have a couple of statuses where you can change the description of the status. And I did this because, again, if you want to use this project for a different purpose, you might want to change this text. So then the messages that you get or the things that you see on the screen is going to be different. So if you change any of these, then just push on the inject node, and I configure this information to be stored in a context. And I have the file context storage enabled, so I configure this to be stored in the file. If you don't have a file context storage, then make sure that your inject node is set to inject in the beginning. So if your Node-RED restarts, then it pulls the latest settings into the flow. Otherwise this function is going to give you an error which says it's there is no settings. So once you have all the settings, this function node, which does all the logic, is just going to work. You don't have to modify anything here. There are no more settings that you would need to change here at all. So the only thing you would need to do is you need to change this inject node. So again, based on how I did my YAML file, my weights are coming in this topic. So it's water scale/scale/state. So of course, if you want a different topic, then you need to modify this one as well. And if similarly, if your ringlight command topic is a different one, then again you would change this to water scale/ringlight/command. So in the YAML file, I have a device name right in the beginning. So that is the first part of the MQTT topic. So if you change that device name, most probably your MQTT topic is going to change as well. So you need to make sure that those are updated here. And this is a ringlight. That's the test ringlight, and there is another one here, which is also the ringlight. So that's what the code uses to send the notification, and you can use these to send, just test it out. I mean, I use this to test the various effects, how they work. And yeah, so that's basically the initial setup. And then this is how I configured the logic to work. So this big message node is going to process messages every time the status changes. So you see the empty status is when the bottle is removed. This is when the bottle is refilled, so the weight increases. This is the reduced, so the weight is reducing. This is the first alarm, and that's the alarm reminder. So that comes after half an hour. That comes after every subsequent 5 minutes. And I also have one which says the goal is reached. So that's when you reach at the moment, the 2 liter goal that I configured in the settings. And as you can see, each of them are connected to a different change node. So here, this is what it configures the various light effects. So scan, a yellow light, a green light, a rainbow, and a random twinkle. And that's sent to the ring light. And then as you can see, for each of them, I've configured a delay. So when the bottle is removed, this scan is played for 10 minutes. For the others, it's played for 5 seconds. And the rainbow effect that I need to drink is getting played for 1 minute. And after these delays, the light effect is deleted. Or sorry, just so the ring light is turned off. And these are my things for Telegram. I mean, I send myself Telegram notifications. And here, basically, all I send myself is a text that the bottle is removed, and I send the total. So this is the message.payload.total contains the amount that I've consumed today. So that you could see the screenshot in the beginning, so it always sends me these numbers. So I can keep track of how much I'm drinking. But again, you can remove all these if you don't need. You can also break some of these lines if you don't want all the notifications for every single state. By the way, I have 2 which is going to green. Maybe I should change that one. So it's really customizable. You can really change it the way you want it. I mean, you would just keep sending all these messages, and you can decide what you want to do in each of these messages. Send a Telegram message, maybe you can send an email, do the light show, and maybe you can just trigger something else, something in Home Assistant or any other system that you have. And if you want to test the light effects, then again, these are the various light effects that are configured in the YAML file. And then this is how you can turn them off. And here I have also like a 5-second delay. So it's supposed to play each of them for 5 seconds and then turn off. And what I noticed that if I play some of them, for example, the slow random or the fast random, even though I send an off message, it doesn't turn off for the first time. It only turns off for the second time, which I can't explain why. So I don't know why this is happening. Maybe my off message is not correct, but I'm going to talk about that a little bit later. So that would be the initial setup. And now I'm going to go into more details of how this flow works if if you're interested in the programming details. I've already discussed the settings, so that's fine. And I have this update. This update node is only used to show basically this message when the last update was received from the sensor. And because in the YAML file they're configured to be every 10 seconds, it should be, this shouldn't be more than 10 seconds. So if it's more than 10 seconds, then most probably your thing is disconnected or not connected to the Wi-Fi, for whatever reason. But everything comes to this main function node. So this does all the calculations, the state switching, and sending out the messages to trigger all the light effects and everything. And I also have a reset here. So if you want to reset the data for any reason, you can do this. Like you can reset it in the middle of the day and it will forget all the data that you have. And by the way, everything is stored in the context data and it's stored in the flow. I set it to store in the flow. So first of all, I have a scale settings, which is exactly what comes through here. So you can look at this just to make sure that it reads correctly. And then I also have this last data, the scale data variable, which basically holds all the information. So it says the last value. So at the moment, the scale is measuring 23 grams, even though the bottle is removed. So I might have to just recalibrate this because I was finishing the design. I was attaching this big plate on the end. So now I have to take that extra weight into account. And this no change value, this no change stores the number of seconds, I think, when I last drink the water. I think that that's the last one. So the last refill, again, it keeps track of whenever the weight increases, what was the new weight, so it can calculate the consumption basically. And then in the total, it calculates how much I have consumed today. So it's roughly 1.5 liters. And again, there is like less valid value, which stores again the last valid value, which I think it's a real value and it's not some measurement error. And this is the time when the last drink reminder was sent out. 17:40, so about 20 minutes ago. But again, because I removed the bottle, it's not sending me anything anymore. And the state is no change. So this changes whenever the bottle is removed, the drinking filled, that's status changes. And the last drink alarm is again, it is used to know when the extra 5 minutes has expired. Okay, so going back to the function, I mean, this is where I'm going to spend most of the time. So in the beginning, I just read the various settings and initialize some values. So if the data doesn't exist, and this is where I handle the reset topic. So if you want to reset the thing, reset the values. But other than that is just to remember, so this is a function node where the weight value goes in. So it just keeps receiving numbers, which is basically grams measured. Well, in my case, grams measured, but you can configure your YAML to use a different measurement if you want to. So first of all, I added this noise reduction from the data. So again, that just prevents some bad data to be used in case I just put the weight on the scale and maybe there is a vibration in the measurement or something like that. So as you can see, it just waits until I have the last value from the current value is less than this measurement variance. So as you can see, if there is too much difference, then it's just going to, it still saves the last value, but it's not going to be the last valid value. But again. So that's how it processes it. But for that reason, this is why I said that all the notifications are a little bit delayed, because at the moment I configured the update interval in the YAML file to be 10 seconds. So let's say if I place the bottle on the scale, then the value is going to go up, which is going to be, you know, different from the previous value when the scale was, let's say, empty. So the first one is going to get ignored because of this function. And then when the next value comes in, which is, let's say, the same value, that's when it's going to say, oh, okay, so we have a new value now, and it's a high value, so I probably refilled the bottle, and then it's going to, you know, use that state, use that value and change the state that the bottle got filled. But because the measurements are coming every 10 seconds, so that's likely like a 20-second delay. But again, like, you're not going to drink that often or that frequently anyway, so I don't really think this is a problem. But if you're really bothered about that, you can change the update frequency in the YAML file to, let's say, I don't know, 2 seconds or 5 seconds. And then we check what was the last field value. Then we update it, and then we determine this, the state. Again, if the weight is less than the empty weight, then we just don't do anything. So that's why I said that it's then we say that the scale is empty, and that's it. And if the weight is less than the last valid value, -1. So I added this -1 value because what I noticed that sometimes the bottle was just sitting there and then it would register or like a 1 gram reduction. So I think maybe there is a little bit of drift in the values, or I'm wondering maybe this is just evaporation. I'm not really sure, but these tend to come up like once a day. So I thought, let's just look for 2 grams of difference, and that it seems to be, you know, that steady with my setup. So with this strain gauge, it never measures anything incorrectly, so all the notifications are correct. Yes, I was either refilling or drinking the water, so that works just fine. So this is a good way of doing that. So this -1. And yeah, so then if the difference is more than 1 gram, then we will say that, okay, so the weight is reducing, so we are drinking water, and then it starts calculating all the things that I have consumed, and it checks whether I've reached the daily goal, and then it will send out a message that the goal is reached. Otherwise, it would just send out a message that the amount was reduced, so the water was consumed. And if the weight is more than the previous one by 1, then assume that the bottle got refilled. So we measure this new weight as the new filled weight of the bottle, and then we would be able to start calculating the difference from that one. And if there is no change, then, well, obviously there's no change. The bottle is just sitting there. I wasn't drinking. And then again, we check the daily goals because we don't want to send additional reminders if we already reached that. But other than that, we will check the no change value. Okay, so this is seconds. And so we divide it by 60, and then we check whether that's more than the drink alarm, which in my case is 30. And if that's the case, then we send out this alarm. And then we also set this last drink alarm. So we know when the last alarm was sent out. And then anything after that, we will use the alarm reminder. So the first one is a 1 alarm, and then all the subsequent ones are the alarm reminders. And that's it. And at the end, we just store the value just to make sure that we update everything in the context, and we update these statuses here. And at the moment, I can see that it is just sending alarm for me. So now we can see that the last drink alarm just get triggered. 15:44, which is, I think that's the same time, because then I think that's probably a summertime difference, or something is a little bit off in my server time. But anyway, so this just happened because I can notice that the colors have changed. So it noticed that I drink the water. that I need to drink the water. And if I put the bottle back, I mean, it's already empty because I've drank all my water. So maybe we should see the, maybe we'll send a different status then. You can see this 123. So the first reading comes through as red because then the difference is high. But then, yeah, you can see that now the 123 is accepted because the two consecutive readings are within the tolerance. And now because the weight has increased, then it says that, oh, the butter got filled. So the new weight is 123 grams. And then again, another 123 came in and it says that, oh, there is no change because it was the same before. And I think if we refresh it, then we can see that the new last fill value is 123. I haven't consumed anything. And well, the last drink time was this. The drink alarm got reset because I just refilled the bottle and there's no change. So again, the half-an-hour timer starts again. So of course, the half-an-hour timer restarts every time I fill the bottle or I was drinking water. Well, that's the way I designed it. And that's pretty much it. And you have a debug node, so you can see these values coming out as well. So this was the failed message. That was the no change message. Reducing message. Yeah, no change. No change because probably there was an alarm or something. No, that's just no change. And of course, I think I don't do anything with a no change. Yeah, I mean, I don't send any notification on that. It just happens. This information just sent out. So if you want to capture that for any reason. But yeah, I probably don't need that. So yes, so as I said, I'm going to put a comment here just to explain how the settings work. And also, I think I'm going to put a comment in here next to all the outputs. Oh, it takes way too long to deploy this small change. And also want to put a comment here as well. For the Telegram messages, I'm using my own, I have a whole subscription service around that. So this is why it says service 24. I have a complete video on how that works. But if you're just using Telegram, like, you know, sort of like out of the box, you would change this to service ID and your service ID. So the message is sent to you. But I'm going to show you how that, again, I'm going to leave a comment here. And then you can change this one to a Telegram sender node. But again, if you want to go do emails, then you can change it to an email node. And in the beginning, I already mentioned this whole ringlight setting, or yes, the ringlight setting. And it took me a while to just figure out how it actually works, how you need to send the information to ESPHome in order to, you know, generate the ring light. So you need to send this message, and it looks like that you need to send this complete message, otherwise it's not really recognized. And it has a couple of things that you might not always use. So there is an effect, which can be any of the effects that you included, that you've configured in your YAML file. So you have those various effects, each of them has a name, so that's the effect here. You have the color mode, which I just realized that this actually should be GBR, I think, because that's how it is configured in the YAML. And probably that's the reason some of my colors are off, because I think the red is okay, but some of them are swapped around. So anyway, probably I should change this one. And then of course you see send the state. So if you want to turn off your ring light, then your message says state is off, and then it just turns it off. Otherwise, if you want to do anything, like you just want a single color, then the effect is none, the state is on, you specify the brightness, so anything from 0 to 255, and then you specify the colors. So RGB, so if it's 00255, that's a full green color. If you want a yellow, then I think I have my text and some of the other things around. So okay, that was a blue, sorry. I haven't changed the text. And if you want a green, then obviously the G is 255 and the others are 0. But again, you can just do any color. And if you want to have a scan, then this is how you do a scan. And sometimes whatever you specify in the color, it will get ignored because the configuration contains the colors as well. So again, if you look in the YAML file, you see that for some effects, you actually specify, for example, a random effect is going to pick colors randomly. So you don't have to, so anything that you specify here is going to get ignored because then it just picks a color randomly. Or exactly the same for the rainbow. So you specify that the effect is rainbow. It doesn't matter what you set in the color because it's a rainbow effect. So it would just pick, start rotating all the colors. So the only thing which matters here is you can specify the brightness and the state is on. So that's how you control the LED strip. I didn't find any ways to control individual LEDs within the, well, it's not a strip, it's a ring, but it's essentially the same thing. So I don't know how you could lit individual LEDs unless you have specified it in the YAML file. But again, I'm mostly using some simple effects, the scan, the random twinkle, the rainbow, and then static colors. And the good thing about each of these static colors that whenever you call them, and when you call them like here or when you off, there is an automatic small fade in and fade out. So it's not just a very harsh blink, but it's like, comes on and then goes away. So that's nice. But I think that would be all about this project. I think I've described everything that I wanted to share about this and how you can build it and how you can customize it. But and of course, all these links are going to be done in the video description. I didn't spend a lot of time to talk about the 3D model, but I'm going to include the STL files and also the Fusion 360 file for the whole thing. If you want to change my design, and obviously I've already mentioned the part that I used the 3D printed part is from 2 parts. Mainly because I was printing this side skirt, the wavy skirt from a translucent material, and for the base I just used just a random color that I had lying around, and I also had some 2 sort of like round shapes for the actual plate on the top of the weight. But again, you can substitute it with any size of plastic or acrylic or wood as well. So it's really up to you how you do that. So I think that will be all for today. Thanks for watching and hopefully see you in the next video.